Hello everyone, this is the video for chapter 10, lesson 6. In this lesson, we're going to take a look at how to find the distance between 2 points on a coordinate plane and how to find the midpoint between 2 points on a coordinate plane. So let me give you a little bit of a visual. So there's actually a formula for each thing, distance and for midpoint, but we'll start with the distance. So the distance formula, you'll actually look at this pretty heavily in geometry. So this is a good kind of preview to what you'll see next year. But let's say I have a point here and I have a point here, okay? And I want to find the length between the two. I want to find the distance between the two. Now, normally, if we had like a horizontal line, let's say I have a horizontal line here, we could probably just count the boxes and say, oh, it's like, 6 boxes apart, these 2 points. So the length is 6. However, it's a little more confusing when you have a diagonal line because you can't just count the boxes anymore. So this distance formula, if you're curious about where it comes from, it actually comes from the Pythagorean theorem. You're actually turning this diagonal into a hypotenuse of a right triangle. And then we've rearranged the Pythagorean theorem in order to find just C. And this is all related to a coordinate plane. So I'm not going to go into all the details, but the distance formula is right here. It's the difference of the x's squared, so x2 minus x1 squared, and then plus the difference of the y squared, y2 minus y1 squared, and then all of that square rooted. Okay, so that is the distance formula. And so what's your x1, what's your y1, what's your x2, and what's your y2? Well, similar to I guess like looking for slope and stuff like that. Between 2 points, you've got your x and y for 2 points. Well, we're looking at 2 different points. So in some way, we're calling this like my point 1 and the second point my point 2. So everything that's point 1 is going to be x1 and y1. Everything in point 2 is going to be x2 and y2. And so if you just label your points and plug it into your equation, it should be pretty simple, and you can use your calculator to help you. So when we write this out, it's going to be square root of parentheses x2 minus x1, so 1 minus 5 squared plus y2 minus y1 squared. So don't forget, if there's a negative, to put that in there. And it's subtraction. So if I'm subtracting just a positive, it will be, minus 3 right there. And then you can get your calculator to help you if you want to. 1 minus 5 is -4. -4 squared. Let's talk about this. If you plug this in without a parentheses in your calculator, you're going to get 2 different answers. This with a parentheses is a positive 16. This without a parentheses, if you plug it in your calculator, I'm just saying, if you plug it in your calculator, you're going to get a negative 16. And this is where the most mistakes happen with this distance formula is you're just plugging it in your calculator, using your calculator to help you out. But these little details, if you're not careful with them, are going to mess you up. So I would encourage you to try to do this mentally. -4 squared is positive 16. And then I have -2 minus 3. So I'm going to add the opposite. And this is -5 squared. So -5 squared is positive 25. And then you're going to add and then square root everything. So I have 16 plus 25, which is 41. We're going to square root that. And then you can write your answer as a decimal. You don't have to simplify this square root like we've done in the other lessons. So when you let's round to the nearest tenth or so. So this would be 6.4 units because it's a length. So we should have units, but we don't know, is it centimeters, feet? I don't know. It's just on a coordinate plane. So it's 6.4 units long is the distance. Okay, looking over here. If that helps you, label your points. So I'm going to do that. X1, Y1, my first point. X2, Y2, my second point. Now I'm going to do -5 minus -7. So when I subtract a negative, It's the same thing as adding a positive. So I'm actually going to just like write that as I work this out. Plus -8 minus -2. And so subtracting a negative really means adding a positive. So I'm going to rewrite that there. And let's work it out. So 5 minus 7 is -2. -2 squared is 4. -8 plus 2 is -6. -6 squared is positive 36. Now I have 4 plus 6, which is square root of 40. And we plug this in our calculator. The answer is 6.32 units. If you don't want to simplify on your calculator and you want to actually like factor it out, I will accept that answer as well, right? So you have 2 and 20. 20 will be 2 and 10. 10 doesn't really factor out into anything smaller. We've got a pair here. You could also say it's 2 times square root of 10. All right. What if we have the distance, they're 5 points apart, but we're missing like part of a coordinate. So here we have our coordinate 1. Here's our second point, but we're missing like the x value in the second point. So if you know the equation, all you have to do is plug in what you know into the places that they would belong to in the equation. So they're 5 points apart, meaning that is the distance. I'm going to say 5 equals square root of x2, right? So that's actually my a. That's what I don't know. Minus x1 squared plus y2 minus y1 squared. Okay. Now I'm going to have to think through the order of undoing a problem when I have an algebraic equation. And we've practiced this a little bit in a previous lesson. So if I have a square root and I'm solving for a variable, first thing I have to do is square both sides so that the square root goes away. So we square both sides. Now I have 25 equals a minus 4 squared. And you know what? I'm going to also just simplify this because these are all known terms. So 3 minus 7 is -4. -4 squared is 16. So what I have here now is a minus 4 squared plus 16. 25 stays over here. I'm going to subtract 16 on both sides. So you're just working backwards. And then I have 9 after I've subtracted. And then I have a minus 4. And so the opposite of squaring something, what do you think it is? If you're the opposite of squaring something, we've done the opposite of square rooting. So now we're going the other direction. Square root. So when you square root a square, that all goes away. It cancels. So I have square root of 9. And here's the tricky thing is when I square root 9 and I'm solving for a variable, I'm actually going to bring this up here, that it is actually a positive or -3. And now we have to split this into two equations as a 3 equals a plus or a minus 4, and then a -3 equals a minus 4. So now we're going to work two separate equations out, and one of them is +7 and one of them is +1. So the value of a can be +7 or it can be +1. And if we were to graph this, you could probably use a visual to help you see, okay, what's going on here, right? I've got 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. This is one of my points. And then my second point is that it's either +7, 3, 1, 2, 3, 4, 5, 6, 7. So here, or +1, 3. And you can see like, it's almost like I'm making like an equal or isosceles triangle. Like these two sides, they're completely the same. So you can see I can actually have either point a 7 in place like 7, 3, or I can have a 1, 3, and I will still have a point that's created, one right here or one right here, that is the same distance from this point given to us that's 4, 7. So if if you're not sure what's going on, graph it out and see the visual. What's going on visually? Does this make sense? Do my points look like, these two separate points that I've found the x coordinate of, do they look like they're equal to the point that's given to me, 4, 7? If they don't look the same, then you might have done something wrong. You want to go check it. All right, let's do this again. So it says find the possible values. So possible values potentially more than one, right? Between 3a and negative 4, 5. The distance is square root of 558. Sorry, square root of 58 points apart. So 58 square rooted is the distance. Then we have our difference of the x's plus the difference of the y's. I don't know what y1 is, so I'm left with that. I'm going to square both sides to get rid of this. What's beautiful about this is I have a whole number now, 58 equals negative 4 minus 3. I'm actually just going to work this out. Negative 4 minus 3. So add a negative 7 squared plus a minus 5 minus a squared. This will be 49. I'm going to subtract 49 from both sides, so this goes away. And I have a 9 again. 9 equals a minus, sorry, keep reading it backwards, 5 minus a squared. So opposite of squaring is to square root. Square root both sides. Square root of 9 is positive or negative 3. Back to kind of the problem I looked at previously. Now I have to split this off. I've got a 3 equals 5 minus a, or a negative 3 equals 5 minus a. And let's get some room here. Plus 5 on both sides. And I have 8 equals negative a. Over here, negative 8. Wait a minute. I made a mistake here. This is not plus 5. This is minus 5. It's like, why am I getting the same thing? Didn't think they were the same thing. Okay. Wrong. Working it wrong. Minus 5, because this is positive. So now I have negative 2 equals negative a. And then I have negative 8 equals negative a. Now, how do I get rid of a negative in the variables? Divide it by negative 1. So now, I know I'm working both. I'm going to bring my answers here. I have positive a equals 2, because negative 2 divided by negative 1 is positive 2. And then I have a equals positive 8, because negative 8 over negative 1 is positive 8. So these are my two solutions in terms of, I guess, my two possible values for the y if I have a distance of square root of 58 apart. All right, on to a newish topic, midpoint. So that is basically where I have 2 points. Say, we got these are my 2 points. And there's the length between them, the distance. But I want to find the location of what's exactly in the middle. So this would be what we call the midpoint. It's the middle point between 2 points. And if I looked at their distance, this distance would be congruent or equal distant to the second half. So it's splitting 2 points into like the middle location, the midpoint. And really, how you find that is by averaging, adding the x values, adding the y values, and dividing by 2. Finding the average of the x, finding the average of the y. And so if we can use this formula to help us with our midpoint and label our correct points, then all you have to do is plug it in. So again, x1 and y1 for my first point, x2 and y2 for my second point. So to find the midpoint, it is 12 plus -8 divided by 2. And then we're going to put a comma between. And then the 3 plus 3 divided by 2. So just be really careful because it's easy to mix up these formulas. This one we're adding. We're adding the 2, not subtracting the 2. So 12 plus -8 is 4. 4 divided by 2, parentheses, or comma, and then 6 divided by 2. Okay. Simplify. The midpoint is 4 over 2 is 2. 6 over 2 is 3. What ends up happening is when you put that, separate these two problems with a parenthesis or a comma in between, you're finding the average of the x's, comma, the average of the y's. So what's going to work out is everything is going to simplify down to the x and y value, and that becomes the location of your midpoint. So the midpoint is 2, 3 as a coordinate. All right, so if you want to pause and work some of these out, you can. I'm going to work these out. And you can check your answers and see how you're doing. You might get a fraction at times just because when you're like dividing by 2, it might not simplify all the way. So just write it as a fraction or a decimal. Either one's fine with me. But the average of the x's, so add your x's, divide by 2, comma, add your y's, divide by 2, comma, or not comma, close your parentheses. Now I have -1 over 2, and I have 0 over 2. Simplify. That is -1/2, comma, 0. 0 over 2 is just 0. This is my midpoint. Last problem here. Add my x's, divide by 2. Add my y's, divide by 2. Look at this as an ordered pair. 9 over 2 and 12 over 2. Simplify. We could look at this as 4.5, comma, 6. And that's my answer. Right. That's all I have for you today. So 2 big formulas. Just got to know how to identify the information and plug it into the right equation and solve that way.